All right, today we are working on day 2 of section 6.1. Our objective today is to solve problems by writing and using proportions. So if you thought yesterday was pretty easy, then today will hopefully be pretty easy as well. First, for our warm-ups, we are simplifying these ratios. What's the first thing that we're looking for when we simplify ratios? That would kind of come second. You're on the right track, though. Micah, what do you think? The units need to be the same. So if the units aren't the same, we keep the smaller units. But if the units are the same, we can just move on and start simplifying. So on number 1, are the units the same? They sure are. If you would rather write it as a fraction to help you simplify, that's fine. Both top and bottom are divisible by 3, so this becomes what? Good. 4 kilometers to 1 kilometer. You have to keep the 1 on the bottom. Our ratio involves 2 numbers, so we can't just put 4 or 4 kilometers and be done with it. If you don't have both, it is not correct. On number 2, what do we notice? Units are different, so we have to do something with these units. Which units are we going to keep? We want to keep the inches. So what scale factor or conversion factor am I using? Good, 1 foot over 12 inches. Would it be okay if I put 12 inches over 1 foot? No, because then my units aren't going to cancel out correctly. So we drop the feet, we keep the inches. What do we get in the numerator? 36 inches. In the denominator, 108 inches. These are both divisible by 36. 36 divided by 36 is 1. 108 divided by 36 is 3. And we are finished. Yes, ma'am.
Does it matter if you have them backwards, like you have the 3 inches and 1 inch?
Yes, that would matter. So if they've got 36 on top, that's smaller than 108. We better keep the small number on top. Okay. Good question. Other questions? Okay, so if you have this flipped and you had the 3 on top and the 1 on bottom, it would not be the same, so it would not be correct. All right, number 3, how do we solve proportions? Multiply diagonally, we take the cross products, cross multiply, any of those are the same description. So that means we are multiplying 4 times 15, that gives us, we are also multiplying 5 times x, which is 5x. What symbol goes in between those products? An equals sign. For some reason, some students like to try to turn these into fractions right away, which doesn't really work out. Last thing to solve, divide by 5, x equals 12. Questions, concerns on number 3? All right, on number 4, we are asked to simplify. We saw problems similar to this in our warm-ups yesterday. So remember yesterday we broke up our radical. Ari?
You can take the square root from 36 and 4 and multiply it, and then 8, you can break it down to 4 times 2 and take the square root of 4.
Good. So we can start off by thinking about these as individual square roots that get multiplied together. The first 2 are perfect square numbers, so we can take their square roots pretty easily. Square root of 36 is square root of 16. And like Ari was saying, the square root of 8 isn't a perfect square number, but it can simplify. What does it become? Majay? 2 root 2. So if you need to see that factor tree, 8 breaks into 4 times 2. 2 times 2, we have a pair. That's why 1, 2 came outside. The other lonely 2 over here stayed inside. The last thing we need to do is multiply all of those coefficients out front together. 6 times 4 times 2 is 48. And underneath the radical is still a 2. Could I simplify this further and write a 96? Why can't I multiply the 48 and the 2? Good. The 2's under a radical. The 48 is not. So they are separated. You cannot multiply them together. Anything else? Ready to keep going? Some people seem to be. An equation that states that 2 ratios are equal is called a proportion. This should not be brand new information to you. We've been solving proportions in the warm-ups. What could be new to you would be the terminology we use to describe the pieces of a proportion. So AB equal to C over D is a generic proportion. So A, B, C, and D could be numbers, they could be expressions, they could be different variables. But in general, anything that's in the same position as B or C in this case are called the means. Anything that would be in the same position as A or D is called the extremes. Personally, I remember this by thinking about how I would write this out. If I were to write out the proportion from beginning to end, A over B equals C over D, what would generally be the first thing I would write? The A, right? If I'm writing A over B, A is the first thing I write. Generally, what would be the last thing I would write? The D. So first and last are extremes. They're on the ends. The other ones in the middle are the means. Middle means. Now, if that doesn't click to you or make a whole lot of sense, that's just how I remember it. If you just want to memorize it, that's fine. If you have some other way of thinking about it, that's fine. But you need to be able to identify means and extremes. Questions about them? Okay? Cross product property is nothing new to us. It's just worded a little different. The product of the means is equal to the product of the extremes. And if I were to have asked you to cross multiply this proportion, I believe many of you would have told me to take A times D, those are the extremes, and set it equal to B times C, which are the means. Or you could have done it the other way. Of course, we should know that the order of multiplication doesn't matter. Those are the same thing either way. Questions, concerns? Need more time. Moving on. All right, we've got some proportions. This first one, I think that you could probably solve on your own the first day of geometry in August. I think most of you would have gotten this. We are going to multiply 8 times 27 and set it equal to what? 24x. Okay, 8 times 27, 216. Last step to solve. Divide. What do we get for x? Are we all okay with that one? Okay, that one's pretty straightforward. Nothing too hard about the math involved there. The next one's also not too bad. There is one little thing we'll have to keep in mind. To start it off, we're going to take 2 times 4x. What's my other cross product?
5 times x plus 3.
Okay, when you do this, what symbols do you think you need to put around the x plus 3? Parentheses. We have to multiply 5 to that whole denominator, which means we are going to do what? Distribute. So if you were to just write it 5 dot x plus 3, what that means and what most people would do would be write 5x plus 3. That is not correct. We have to remember to distribute if there's more than one term in a ratio, so top or bottom. Questions about that? Okay, that's the only real tricky part about this problem. So let's keep it moving. 2 times 4x is 8x. When we distribute, we get 5x plus 15. To solve it, we need all our x's together. So what would you do? Subtract. 3x equals 15. Last step. X equals 5. Questions about letter B? Again, that's one most of you probably would have gotten right on your own anyway, as long as you remembered to distribute. All right, letter C is going to be the trickiest of them all. Easy part is taking 2 times 7, no big deal. But now for our other cross product, what symbols do you think I'm about to put in there? Parentheses around everything. X plus 3 times x minus 2. How in the world do we handle that? Detriana?
I put x squared plus 3x minus 2x minus 6.
Beautiful. Now, if you're old like me, somebody might have taught that to you as FOIL, first, outer, inner, last. Has anybody ever heard of it that way?
Yes.
Okay. If you're not as old as me, or don't have siblings or whoever that helps you with your math as old as me, you might have heard it as double distribute. Anybody heard it that way? Okay. So either way you want to think about it, it doesn't really matter to me which way you learned it, as long as you were to get the same thing as Detriana. Now, if you went ahead and combined your x's, I would also be okay with that. That should be our next step. 14 equals x squared plus 1x, or just x, minus 6. Before we keep going, I will pause here if we have questions. Anybody have questions about what Detriana did to get her polynomial here? We all remember that from Algebra 1? Mm-hmm. Okay, good. If you don't, you need to see me or perhaps attend some tutoring when it kicks back up next week, because that's a skill that's required for this class. Now the next part, let's see who really remembers their algebra. What do we have to do?
X factor.
Not yet. We will get 2 answers, but we're not ready for that yet.
You just add the 6.
No. You're closer.
Square root.
Not yet. I tell you,
Don't you have to find like 2 different things like x percentage and x?
eventually,
Oh, the factor.
eventually.
You're gonna subtract x.
Nope. What do you think?
Don't you have to get 0 on your end?
We need 0 on one end before we can factor. We can't factor this without it equaling to 0, or we're just going to end right back where we started. Okay, it won't change anything to factor this back out. We'll just get the same parentheses we had here. That doesn't get us any closer. If you're going to try to solve a quadratic by factoring, it has to be set equal to 0 before you start. And how are we going to make that happen? Subtract 14 on both sides. That is a big step. Even though it's not a hard step, we have to remember to set it equal to 0 first. Now we can do what many of you were wanting to do with the two answers, X factor, however you want to think about it. There are many ways that this gets taught. But oftentimes in Algebra 1 with a leading coefficient of 1, people made the X. What number did you put on top? The 1 from the middle. What number went on bottom? The negative 20. I didn't make my X very big. So we're looking for two numbers that add up to 1 and multiply to, I'll tell you, what are they? -4 and +5 are what do that. So I'll continue my work off to the side. Don't drop your 0 equals. That should still be there. 0 equals, now using those numbers that Atea gave us, what should go in those parentheses? X plus 5, X minus 4. I don't care if you put the X minus 4 in the front and the X plus 5 in the back. The important part is that you have the correct sign with the correct number. From here, what should we do? Nope, because that's going to land us right back where we just were. I like the word set.
You have to set something over the sign of 0 so you can start.
Set each factor equal to 0 is the mathematical way of saying it. So X plus 5 gets set equal to 0, and X minus 4 gets set equal to 0. This is the zero product property. If two things multiply to be 0, at least one of those things has to equal 0. Then the easy part, we solve these. The first one we get X equals, the other one X equals 4. That was a fun throwback to Algebra 1. Anybody have questions or concerns about it? For sure. There's a lot of old review from algebra all in that one little problem. We're ready to move on to the back? Okay. On we go. The geometric mean of two positive numbers A and B is the positive number X that satisfies A over X equals X over B. Just as a fun reminder, what was an arithmetic mean? What other word do we usually associate with the word mean in math? Usually it's in like statistics, like mean, median, mode. Average, very good. So the arithmetic mean is the average. It's when we add a bunch of stuff up and divide by however many terms there were. So usually when you hear the word mean, it refers to the average. That's why the word arithmetic is not really there very much. But when we talk about a geometric mean, that means that X satisfies this proportion. So if we are finding the geometric mean of these two numbers, that means instead of writing an A and a B, we'll put in these numbers. The X will stay there because that's what we're looking for. X is the geometric mean. So I set up my proportion. 24 over X equals X over 48. To solve this, I need to multiply 24 times 48. I also need to multiply x times x. 24 times 48. Ooh, little 1,052. Okay. Equals x squared. Then we would need to square root both sides. Okay, now if you didn't want to multiply the 24 and the 48 together yet, I would be okay with that if you wanted to leave it as 24 times 48 like this. Either way you do it, you're going to end up at the same answer, or you should. But if it's easier for you to break these down separately, that's fine with me. So, for example, the square root of 24 would simplify. We'll just write this one out. 4 times 6. 2 times 2. 6 is not going to give us a pair. So the square root of 24 becomes what? 2 root 6. The square root of 48 would break down into 16 times 3. 16 breaks down into a pair of 4s. You don't really need to take it any further. So this becomes 4 root 3. Now the tricky part, we can multiply these back together. 2 times 4 is 8. So I'll take this away while I'm showing my work. 2 times 4 is 8, and 6 times 3 is 18, but then 18 breaks down. So we can also take another 3 out. So we would have 8 times 3 root 2, which becomes 24 root 2. Now, if you wanted to break it down all the way from 1152, that's fine. You would end up in the same place. What I don't want you to do is give me a decimal answer. Some way, somehow, you've got to break down this radical to simplify it. If you want to start with 1,152 and make yourself one big factor tree, that's fine. If you want to do it in pieces to simplify it a little bit and then recheck to simplify again at the end, that's also fine. Do we have any questions about any part of this problem? The setup, the simplifying, the solving. We all just feel warm and fuzzy about it. Can I take away all this work and bring back the other problem? Yes, no, maybe? Okay. Well, I don't have to take all of it away, just the end of it. Okay, in my opinion, this next one will be a little bit easier to simplify from the get-go because we have a perfect square number. So on this one, what is my proportion?
36 over x equals 6 over 54.
Very good. Okay, the numbers they give you are your extremes. The geometric mean means the means are both x. When we cross multiply, I am not going to multiply those together right away. I will go ahead and just write an x squared instead of x times x. To simplify it, what do I need to do to both sides? Take the square root. The square root of 36 is easy because it's 6. The square root of 54, did anybody simplify that one? Ooh. What did we get? Let's just break it down together. What would we break it into? Okay. 9 will give us a pair of... Will 6 give us any pairs? Nope. So this is 3 root 6. Are you good with that? Okay. Last step is to multiply those together. So what does x equal? 18 root 6. We don't have to re-simplify on that one, since we still know a 6 won't give us any pairs when we break it down. Bless you. Questions, concerns about example 2? Yes, ma'am.
Okay, I see.
Are you sure?
Yeah, why thought the 6 goes on the outside? That's what
So this 6, yes. So we took the 6 times 3 on the outside.
No, from the when you square root.
Oh, this one?
Yeah.
So whatever is alone or doesn't have a pair has to stay inside. So I always say if you don't have a friend, you can't play outside. That's what my mom always told me. Can't play outside unless you have a friend. Safety in numbers. Stranger danger? No? Okay. Questions, concerns? Okay, we'll keep going. Switching gears a little bit. The points, -2, 3, 4, 5, and x2 are collinear, which means they're on the same line. Use slopes to write a proportion to find the value of x. Now, if these points are all on the same line, then it shouldn't matter which 2 points we take. We should always get the same slope. If they're all on the same line, then any pair of points should calculate the same slope. So we're going to start this problem by finding the slope of the line, which means we want to use the 2 points where we know all the numbers. So if you want to write yourself some little steps, step 1 would be to just find the slope. In order to do that, I better know my formula for finding slope. M equals, we don't start with x's, we start with y2 minus y1 over, good. So let's do that using the points that I know. My slope, what am I plugging into my numerator? Over. Very good. Remember, when you subtract a negative, it turns positive. 5 minus 3 over, simplifies to be, okay, so that is definitely the slope. The second thing we are going to do is kind of find the slope or start slope with the unknown point. So that means you kind of get to pick which of the known points you want to use with it. We have to use the unknown one as one of our points. Which other one do you want to use? Okay, it doesn't matter to me. If you were to use the other one, your work will look a little bit different. That's fine. So we start finding our slope. We're not going to be able to finish it, but we'll start it. What would go in my numerator? Okay, we could do 2 minus 5. If you did it the other way around, no big deal as long as you're consistent in the bottom. So setting it up this way, what's going in the bottom? X minus 4. We can simplify this a little bit. The top would become -3. Can we do anything to simplify the bottom? No, we don't know x, so it's just x minus 4. The last part of this comes from what we talked about at the beginning. If all these points are on the same line, then anytime we find the slope, it should be the same or equal. So set slopes from 1 and 2 equal to each other. From steps 1 and 2 equal. That's how we write the proportion. 1/3 equals, what's going in the other half of this? Good. Negative 3 over x minus 4. Do we have questions on any of these steps? Okay. Then this should be pretty easy for us to solve. We have to cross multiply or take the products of the means and extremes. 1 times x minus 4 is x minus 4. Now, if it were something other than a 1, we would put the parentheses and distribute, but I'm okay with you guys knowing that multiplying by a positive 1 doesn't change it. Our other cross product is negative 9 when we take 3 times negative 3. So I guess my fourth step here, if you need it, 4, is to solve the proportion. Last step to solve this would be at 4, we get x equals negative 5. Done. Questions about that one? Okay, so using those same exact steps, I want you to try the next example on your own. The steps aren't any different, even though you are finding a y instead of an x. Do you need me to leave this one up here, or did we get all this down? Got it? Okay, I'll go ahead and switch it. So same steps. See what you can come up with for y. We'll talk about it in a few minutes. All right, let's start this problem and see what we come up with. The first thing we should have done was find the slope using both the points that we know. So what did you plug in to find the slope? 5 minus 3 over 7 minus 2. 5 minus 3 is 7 minus 2. Good. That is our known slope, the definite slope of the line. The second thing we do is start trying to find the slope with the unknown point. So we know we're using this one. What other point do we want to use? 7, 5. If you use the other point, that's fine. Your work will just look a little different, and that's okay. So we start finding the slope. What goes in the top? What is it?
5 minus y.
Okay, you could do y minus 5 or 5 minus y. I'm going to do y minus 5 just because I like the variable being in front. If you did it the other way, that does not make it wrong as long as you're consistent with your denominator. So if I'm putting y minus 5 in the top, what has to go in the bottom? Okay, negative 3 minus 7. If you did it the other way and you had 5 minus y, then in the bottom you should have 7 plus 3. We can simplify the bottom part of this. What is negative 3 minus 7? Negative 10. Okay? Questions? Concerns? Now we need to set our slopes equal to each other to make it into a proportion. In order to solve this proportion, we have to cross multiply. So we take 2 times negative 10. That gives me negative 20. The other way, we have to take 5 times y minus 5. I'm putting parentheses in there so that I remember to multiply to both of them or distribute. So when I distribute, what do I get? Good. Next thing would be to add the 25. We're working on getting y alone. So we end up with 5 equals 5y. Last step. Divide by 5 and y equals 1. Okay, if you did your work differently, you still should have gotten y equals 1. If you have any questions about it or want to see different work? Okay. Need more time with this slide up there? Okay. All right, your homework is, of course, out of the textbook. It should also be on your handout. Don't forget that you also have that PSAT 10 practice that is due on Friday that you could be working on. Okay. I don't want it early. I want them all on Friday. So just keep it in your binder. It's hole punched if you need to stick it in there. We'll take them on Friday.